Hey guys, Mr. O'Sullivan here. Hey, I'm going to do a walkthrough of the worked out solutions for the last Unit H test that you guys took. So here we go. I'm going to dive in with problem number 1. It says consider the differential equation dy dx equals negative 2x over y. Find the particular solution y equals f of x to the given differential equation with the initial condition f at 1 equals negative 1. Okay. Well, the first thing we want to do is take our differential equation, and I'm just going to recopy it. Dy dx is equal to, I'm going to move the negative sign up by the 2x. It's kind of like right in the middle there. Could bring it down with the y, but I'm just going to put it up with the negative 2x over y. And the first thing I want to do is separate my variables. So I'm going to multiply really both sides by y to bring the y over to the left side. So I'm going to get y dy is equal to, and then I'm going to multiply both sides by the dx. So I'm going to get on the right side negative 2x dx. Okay, so that's the separation of variables, first step. Then I want to integrate both sides of my equation. When I integrate the left side, I'm going to get y squared over 2 is equal to, and then when I integrate the right side, I'm going to get negative 2x squared over 2, and I can cancel the 2's. Then I have to remember to add my plus c. Okay, so I've integrated both sides. Now my next step, I'm just going to rewrite y squared over 2 is equal to, don't forget that negative sign, negative x squared plus c. And here's where I want to take my initial condition. And I remind myself, f at 1 equals negative 1 means when x equals 1, y equals negative 1. So then I want to substitute those values into my equation. So I'm going to get on the left side, negative 1 squared over 2 is equal to negative 1 squared plus c. So on the left side, I'm going to get negative 1 squared is 1. So I get 1/2 is equal to, and what that is that's like negative 1 times 1 squared. So 1 squared would be 1 times negative 1 is negative 1. So I get negative 1 plus c. Now to solve for c, I'm going to add 1 to both sides, plus 1, cancels, and I get c is equal to 1/2 plus 1, or 3/2. Okay. Now I'm going to plug in the 3/2 for my constant of integration, the c. So I'm going to get y squared over 2 is equal to negative x squared plus 3/2. Okay. And now my goal is just to solve for y. So I'm going to multiply the entire equation by 2. So I'm going to get y squared is equal to negative 2 x squared plus 3. And then I want to take the square root. Both sides of my equation, I'm going to get y is equal to plus or minus, don't forget the plus or minus, negative 2x squared plus 3. Okay, now I have to decide which branch I want to take, the positive or the negative. Well, I look at my initial condition, and it's y equals negative 1. So the only branch that point will be on would be the negative branch. So I have to declare here y is equal to negative square root negative 2x squared plus 3. So that is my particular solution for that differential equation. Okay? Awesome. Hope you got that one. All right. Moving on to number 2, area volume problem. So I'm given the graph of two functions, f of x and g of x. And it says, let f and g be the functions given by f of x is equal to 1/4 plus the sine of pi x, and g of x is equal to 4 to the negative x. Let R be the shaded region in the first quadrant enclosed by the y-axis in the graphs of f and g, and let S be the shaded region in the first quadrant enclosed by the graphs of f and g as shown in the figure above. Okay. So part A, I want to find the area of R. Part B, I want to find the area of S. And then part C, we're changing gears. We're going to find the volume of the solid that's generated when region S is revolved about the horizontal line y equals -1. Okay? Okay, first thing I'm going to do is, since I could use my calculator on this, I'm going to go ahead and I'm going to say that f of x is equal to y1 in my calculator, and g of x is going to be equal to y2 in my calculator. And I'm just going to kind of remind myself, okay, g of x, that's equal to y sub 2, and f of x is y sub 1. Okay? All right, so I'm going to plug those two equations into my calculator. So y1, putting in f of x, so that's 1/4, so I'm going to put 0.25 plus the sine of pi times x, and I make sure I'm always in, since that's a trig function, I want to make sure I'm in radian mode. Check. Yep, always in radian mode. Okay, so that's y1, 1/4 plus sine of pi x, and then y2 is going to be 4 raised to the -x power. Okay, so I've got both those equations in. Okay, and now what I need to do, I'm kind of looking at the two equations, and I can see right here, I'm going to need to know that point of intersection and also that point of intersection. Okay, so I figure, and it looks to me like really all I'm going to care about is going to be the x-coordinate of those 2 points of intersection. So I'm going to find this one here on the left first. And what I'm going to do is whatever x value that turns out to be, I'm going to store that in my calculator as lowercase a. And then for this one, I'm going to store that as lowercase b. Again, just storing those values in my calculator. So I want to find the intersection point on the left first. So I'm going to go to my graph. Just kind of double check that I can see both functions. Okay, I see f of x first. Yep, and it looks like I'm seeing. I just have to make sure that I'm seeing both of those graphs. That's my background there. It's hard to tell. Okay, so now I'm just going to use second calc. I want to find intersect, first curve, second curve, and then I'm just going to kind of move to that intersection point. And it looks like that intersection point is 0.17821805. Okay, so what I want to do now is quit out of my graph. I want to take x and I want to store that as a in my calculator. Actually, I guess my calculator stores it as uppercase A. So that's going to be A in my calculator. This one will be B. Okay, so I stored as A, and then I always double check. Look at A, boom, there it is. Okay, I'll go back to my graph now and find that second intersection point. So I go second calc, option 5, intersect, first curve, second curve, and now I just move my cursor close to that intersection point. Oh, that one's easy. That one's just going to be at 1. Okay, that's at actually 1, 0.25. I didn't even put the y value on that first one. Again, I don't care. Okay, so I've got my two x coordinates of the points of intersection, and now I'm ready to go ahead and start answering my question. So part A says find the area of R. So that's region R right there, and I'm going to set it up. That's going to be, I know that's going to be a definite integral. So it's a definite integral from what to what? Well, it's going to be from x equals 0. So that's going to be my lower bound is 0. My upper bound is going to be what I just stored in my calculator as a. I'm just going to put here x equals a. I'm going to write that a. And now I just have to look. Okay, region R is bordered on the top by y2. Okay, this is it's y2. That's g of x, right? And then on the bottom, that is y1. So I want to put y2 minus y1. y2 minus y1, respect the differential dx. Okay, now I'm going to plug that in to my calculator just like that. So I'm going to go to my home screen, put out of my graph. I want to go to math, option 9, my definite integral template. The lower bound is 0, upper bound is a. Just do alpha a, and then I want to just do y2. And again, the shortcut to get to the y, y2, y1, etc. It's going to be alpha trace. And I want to select y2 first, minus alpha trace y1. And then I want to go to dx. Okay, cross my fingers. And then my answer is going to be 0.064753 ... Okay, and that's going to be the area of region R. Okay, part B, area of region S. Okay, now I'm changing gears. I'm over here looking at region S. Well, again, it's going to be a definite integral. So I'm going to get started on that definite integral. And this time I can see that, okay, I'm going to start at this x value. So my lower bound is going to be a. And my upper bound I'm going to go to right here. And I found that x coordinate at that point of intersection is 1. So lower bound is a, upper bound is 1. And I'm looking here and I can just see, okay, my upper function, draw the line if that helps. Upper function is y1 and the lower function is y2. So I want to switch them, y1 minus y2 dx. Okay, I've already got a in my calculator, so I just have to pull up definite integral template. So lower bound is a, upper bound is 1, and then I got y1 minus y2. So I go alpha trace y1 minus alpha trace y2, arrow over dx. Oh, forgot to put in my dx. Back to that, dx, and area of that region, 0.410362 ... That's the area of region S. All right. Part C, now we're changing gears, doing a volume of a solid. So the volume of the solid generated when S is revolved about the horizontal line, y equals -1. Okay, so I'm dealing with S. So for S, I saw that my bounds were, lower bound was A and the upper bound was 1. So I'm going to start writing that same as I had for B. So lower bound is A, upper bound is 1. And I'm going to treat this as what's happening is I'm revolving it around the horizontal line y equals -1. Well, I'm going to draw some of this. I'm going to draw that line. Just extending my axis down and then here, drawing a line right here, and that's the line, horizontal line y equals -1. That's my axis of rotation. Draw a little arrow around that. Okay. Now what I'm going to do is I'm going to have my 2 radii. Okay. So my first, just going to erase that. First radius, and again, when I draw my radii, I always start where? You got it. The axis of rotation. So that's going to go up all the way through my region. Right there. That's going to be lowercase r. And r is going to be equal to, what's that upper function? Looks like it's y1 minus my lower function, which is going to be minus -1. Now I can simplify that a little bit. That's just going to be y sub 1 plus 1 unit. Okay. So that is going to be, I'm going to put pi out in front here. And then that's going to be my lowercase r. So again, pi r squared is my integrand. There's the pi. And the r is going to be y sub 1 plus 1 squared dx. Okay. Now the next radius I'm going to draw, it's going to be again from the axis of rotation to that first point right there. I go up to the region. I'm just going to draw that. It's going to be my capital R. That's equal to upper function, which is y2, minus my lower function again, which is -1. Simplify that. That could be y2 plus 1. So that's going to be my second part of my second integral. A to 1, same bounds, and this time it's going to be y2 plus 1. y2 plus 1, don't forget, quantity squared dx. Okay, to kind of save time, maybe putting this in the calculator, I'm just going to do it as one single integral, so I'm going to have pi, and then my bounds are the same, that's why I can combine them. And then the first part of my integrand is just going to be that first one, quantity y sub 1 plus 1 squared minus, and then the second one is that second quantity, the integrand from the second integral, y sub 2 plus 1 squared dx. Okay, now this is exactly what I have to put in my calculator. So again, don't forget, remember pi. So we got to put in pi first. So we got pi times the definite integral. You can do times, you don't have to. Math, option 9, that's our integrand or definite integral. So lower bound is going to be a, upper bound is going to be 1. Okay, my integrand, I want to put a pair of parentheses, and then y sub 1, alpha trace y1 plus 1, close parentheses, squared, come down to the, out of the exponent, minus parentheses, alpha trace y sub 2, and then plus 1, close parentheses, quantity squared, arrow over again, and put in the x and the dx. Hit enter, say a little prayer, and we come up with our answer, 4.55876, yada, yada, yada. Okay, that's the volume of that solid that's created by revolving S around the horizontal line, y equals -1. Okay, all right, you guys are killing it. Part 3, the differential equation given as dy dx is equal to x y to the third. Find the particular solution, y equals fx, when the initial condition f at 1 is equal to 2. So again, I'm just going to write right here, remind myself, x equals 1, y equals 2. Okay, all right, so I've got, and I gave you guys a hint just to make sure that we got past the separation of variables part. If you think about it, if you divided both sides by y to the third, you'd have y to the third in the denominator on the left side. You could rewrite that, bring it up to the numerator, and rewrite it as y to the -3rd. So that's kind of was the tricky part on that. So I gave you kind of the first step, separated the variables for you. And now I'm going to integrate both sides. Okay, when we integrate the left side, we're going to have y, right? Now we're integrating, so we're going to add 1 to -3. That's going to give us -2, and then immediately divide by -2, good, is equal to, and then the right side, it's just going to be x squared over 2 plus c. Okay, then I'm going to rewrite that. When I rewrite this, I'm going to move that negative sign kind of out front, just so I don't forget it. Negative y squared over 2 is equal to x squared over 2 plus c. And then I want to substitute in my initial condition, x equals 1, y equals 2. So I'm going to get -2 squared over 2 is equal to 1 squared over 2 plus c. So c is equal to 1/2 on the right side is equal to, well, I have that negative sign out there. 2 squared is 4 divided by 2 is 2. So this is equal to -2. So now when I, subtract 1/2, minus 1/2, I'm going to get c is equal to, cancels on that side. I'm going to get -5/2. That's my value of c. So I'm going to just drop that in. When I rewrite this, I'm going to do the same thing I did with that negative sign. So I got negative y squared, or negative y to the -2, positive 2 is equal to x squared over 2 minus 5/2. Okay, again, I'm just plugging that in for my c. Okay, now I just want to solve for y. First thing I do is multiply all the way through by 2. I'll do this just in 2 steps. So I got negative y to the -2 is equal to x squared minus 5. Okay, now what I want to do is I want to take care of this negative. So I'm going to kind of multiply both sides of my equation by -1, just to flip my sign. So I'm going to get y to the -2 is equal to, I'm flipping the signs here, negative x squared plus 5. Okay? Okay, now, what I can really do in one step, and this is why it's kind of fun with like understanding like the rational exponents, I just want y, right? Well, what I can do is I can, well, yeah, let me kind of go the long way on this one because I don't want to mess you guys up. So what I would do is maybe rewrite the left side of my equation as 1 over y squared. Okay, that's all I'm doing, taking care of this negative x1 is equal to negative x squared plus 5. Okay, now what I want to do is I want to flip both sides of my equations. So I'm just going to take the reciprocal of the left side. I'm just going to get y squared over 1. And then I'm just going to flip the right side, and I'm going to get 1 over negative x squared plus 5. See what I did there? I just flipped both sides of my equations. Okay, now what I want to do is I want to take square root of both sides, and I'm going to get y is equal to, you know what to do, plus or minus square root 1 over negative x squared plus 5. Okay, now what I have to do is I have to select, do I want the positive or the negative branch? I look here, y was equal to positive 2, so I just want the positive branch. So that would be y is equal to the square root 1 negative x squared plus 5. Okay, that was a little tricky. Kind of like gave you a little bit of a challenge on that one. I hope you could handle it getting past the separation of variables. Okay, and last but not least, question 4. Okay, so we're given kind of a graph. It kind of told us g of x and f of x, giving us kind of define the functions here. And I'm going to do the same kind of thing I did. F of x, I'm just going to call that y1 in my calculator. So f of x is equal to y1. And then g of x, I'm just going to say that's equal to y sub 2. Okay, all right. Now, first thing, it says write an equation for the line tangent to the graph of f at x equals 1/2. Okay, gosh, and that was a bonus question. I'm not going to count it against you if you didn't get this one, but hopefully you got it. If I want a line tangent, I'm going to start with my point slope form. Y minus y1 equals m times x minus x sub 1. Well, I've got my x value, so that's 1/2, so I can drop that in, 1/2 x minus 1/2. I need the corresponding y value, so I need to figure out what is f at 1/2. So I'm just going to this, and I'm just putting in 1/2 in for my x and working that out. Well, 1/2 cubed is 1/8. 8 times 1/8 is equal to 1. So that means my y value over here is equal to 1. So I get y minus 1 is equal to, okay, how do I get the m? The m, that's my slope. Well, that's going to be my derivative. So that's going to be f prime at what x value? Well, at 1/2. So the first thing I have to do is find f prime at x. So I'm looking at, that's f of x. So using the power rule, that's going to be 24x squared. And now I want f prime at 1/2. So that's going to be 24 times 1/2 squared. It's going to be 24 times 1/4, which is going to be equal to 6. So that is my slope. So that is the equation for my line tangent to the graph at that point. Okay, part B on the area of R. Okay, well, there's R. Well, gosh, this isn't too bad. I'm going to be integrating from x equals 0 to x equals 1/2. And then I can see that it's going to be, looks like my upper function is y2, my lower function is y1. So I'm just going to write that for B. It's a definite integral from 0 to 1/2. 1/2 is my upper bound. And then my integrand, the upper function is going to be y2, and my lower function is y1. y2 minus y1 dx. Okay, now I got to remember my calculator to put in the new functions for y1 and y2. Don't want the ones I was using from the last problem. Okay, so y1 is 8x cubed. And then y2 is sine of pi x. Sine of pi times x. Close parentheses. Sweet. Okay. All right. So now I'm ready to put in that definite integral. So I clear out of my graph. Go back to my home screen. So I want math, option 9. Lower bound is 0. Upper bound is 1/2 or 0.5. And then I want to put y2 minus y1. So alpha y2 minus alpha trace y1, arrow over dx, and I get 0.193309 dot dot dot. That's my answer. That's my area of R. Okay. Part C, write but do not evaluate an integral expression for the volume of the solid generated when R is rotated about the horizontal line y equals 1. Okay, and I showed you that horizontal line y equals 1. Okay, so this one, we just have to kind of draw our radii and we're done. Okay, so we know this is part C. We know we're going to have pi. Don't forget pi. We know our bounds. Since this is going to be R, our bounds are going to be the same that we just used, from 0 to 1/2. So 0, 1/2. Okay, and now this is my axis of rotation. Okay, so what I want to do, I want to draw that first one. That's going to be, again, for my axis of rotation, I'm going to go down. So that's my first one I'm drawing. That's going to be my lowercase r. So r is equal to upper. That's 1 minus the lower. That's y sub 1. So that's my first radius. So 1 minus y sub 1. That's 1 minus y sub 1. That's my r. I got to square it, right? Pi r squared. There's my pi. Just got to square this. Okay. And I'm going to put both of them into this one integral, and then I'm done. So my next radius, again, from the axis of rotation, this time I'm going to stop right there. So that one's kind of short. Orange line right there. Upper bound, lower, I'm sorry, upper function, lower function. So that's capital R. That one's equal to, again, upper function just 1 minus my lower function is going to be y sub 2. So that's my capital R, that's second radius, so minus parentheses 1 minus y sub 2 quantity squared dx, and I'm done. That is my integral. I didn't have to evaluate it. I just have to write it, and that's the volume of that solid. Okay. All right, guys. Hope you scored 100% on that one. All right. Appreciate all your hard work. Thanks, guys.